I'm Vinceline Bertrand, and I build agentic systems in React, and I've learned the hard way how quickly they can break a UI. So I'm going to show you how to build autonomous workflows in React safely under real constraints. Quick show of hands, who here has taken Theory of Automata? And who here has not? Congratulations, you guys are God's favorites. So Theory of Automata at its core is a formal way of defining languages. So for any given state, there are only certain valid transitions to the next one. Think of it of like a regex, but with better readability. A classic example is a password field. The state is waiting for input. You type a valid, a character, alphanumeric string. That's a valid transition. You hit submit with 3 characters. That's not. So the automaton decides, do we move to account created or do we stay and wait? That's it. States and the rules for moving between them. Hold that thought because in about 10 minutes, that's exactly how we're going to think about AI agents. So Agentic AI promises autonomy, reasoning, planning, tool use. And on paper, it looks simple. But the moment you try to put an agent inside a React app, things start to break. The problem isn't AI. It's that we're treating agents like request response APIs. That there's real capability underneath all of that. But the framing is the problem. It makes it sound like we're summoning something. We're not. We're just writing software. So here's the reality in React. The agent fires off a request. The state gets out of sync with the UI. It retries. You double render. It fails halfway through a tool call, and the component is stuck in a state no one designed. Most of the bugs aren't AI bugs. They're React bugs with an AI trigger. But those aren't model problems. They're front-end problems. There's other things such as race conditions where a user interacts and fires multiple async LLM calls, responses arrive out of order, and still data overwrites fresh results, UI shows the wrong answer, and so on. So today, I'll argue that agentic AI is a state machine problem and show how reframing it this way leads to safer and more predictable React apps. So what exactly is a state machine? Well, a state machine is just a system with a finite set of states that moves between them on events and only allow valid transitions. That third part, only allow valid transitions, is where all the safety comes. At any moment, the system is in one state, and the UI reacts to that state. You already work with states in React every day, such as loading, success, error. A state machine just makes those states explicit and defines what can happen next. Here's the breakthrough. Agentic AI is a state machine problem, not request response, not post get, a state machine. Agents have phases. React needs observable state. As you can see on my slide, hungry is a state, and for you to get to the next state full, you need to eat. And then you use energy, and you go to hungry, it's like cycle of life, basically. Think about what an agent actually is. It runs for a while, its behavior changes over time, it reacts to events, such as user input, to responses, timeouts, and it can fail. This is exactly the shape of problem state machines were designed for. Here's a simple agent lifecycle. There's idle, thinking, acting, waiting for input, done, error, and completed. Notice what's not here. There's no vibe state, no figuring it out state. Every state is explicit, every transition is named. But here's one important thing to remember. The UI renders state, not intelligence. So how do we work around this? Well, lucky you, because I've got 3 React patterns that solves this. Here's React pattern number 1. In my opinion, that's the most important. Think of agents as feature scope machines. Please do not have scope creep on agents. I know in a perfect world, we want one agent to do everything and a half, but that's not safe. On my example on the slide, you can see on the left, that's the unsafe example where one global state is being utilized on 3 different forms, and on the right side, you can see there's different agents for each form in different states. Feature scope agents prevent global chaos. Global agents are how bugs become folklore. On to the second pattern, using hooks as agent lifecycle. Agents have different phases, and the UI shouldn't be static. UI should drive state updates. Hooks make agent lifecycle observable. UI dispatches state changes, not the agent directly. If the agent is thinking, the hook should expose a submit function, or at the very least, it should disable it. The type system enforces your transitions. So this is what it actually looks like in code. Instead of just letting the agent do whatever it wants, force it into a reducer like a state machine. Every action the state has to go through here, no exceptions. When a task starts, we move it into a thinking state. If the model decides it needs a tool, we transition it to acting. If it needs input, we explicitly pause and waiting. And if something breaks, we go straight to failed, not some silent, weird UI bug. And last but not least, guardrails. Autonomy without guardrails is just chaos with confidence. Every transition needs to pass through a guard. Max tries, token budget, tool allow list, human end loop checkpoints. The agent doesn't decide what it can do, you do. UI guardrails prevent bad states, and guardrails protect user trust and developer veracity. You might be telling yourself, okay, cool, but I can just use LinkedIn. Frameworks aren't the holy grail, but for some use cases, they do just fine. The great thing about doing the orchestration yourself is you have total control, and the bad thing is you have total control. Let the front end decide whether a framework is worth it or not. If it's very UI heavy, you should consider doing it yourself. Frameworks are great at orchestration, chaining tools, managing memory, and multi-agent coordination. What they're bad at is the last mile, integrating with your specific React app, your specific UI, your specific user. Orchestration is not the same as integration. Before you start working on your agentic pipeline, ask yourself these questions. And if you're saying no to any of these, you probably don't need agents. Don't force it. You do not need agents for a note-taking app, seriously. If a for loop and a switch statement solve the problem, use those. Agents are expensive, slow, and non-deterministic. Only reach for one when the problem genuinely needs planning. So now that you've completed a crash course on agents and state machines, let's do a little exercise together. I want to make sure you guys have been paying attention. Let's design an agent together. So imagine a form like this, and the user pastes in some messy text, maybe an email or a note, and the agent helps fill in the fields and asks questions when it's unsure, but it never submits the form on the user's behalf. Ryan, he's my assistant.
Right here.
So what agents do you guys think, what states do you guys think this agent will need?
Raise your hand to answer the question.
Randomly pick if no one raises their hands.
Waiting for user.
Okay, that's great.
Who else?
Any other? Pick.
I might pick someone
Yeah.
at random. Raise your hand.
Waiting for input.
One more.
Validation failed.
Okay, those are some great answers. Notice that none of these are API calls. They're states the UI can observe. I would also like to try something else. What events move between states? So what should the transitions be? Let's take the error state, for example. What transition would it take for it to go to the error state?
Thinking state?
What transition would it need for the agent to go to the error state?
Oh, I was saying thinking, but clearly I'm wrong.
I'm sorry?
Thinking.
Thinking?
Thinking? No?
No.
Yikes.
For the error state, maybe there's like an infinite loop that would take it to the error state. Something like that. Or missing information. Invalid inputs, yes. So what should this agent never do? Guardrails. That's pretty straightforward, especially for a note-taking app. Some things are the agent should never auto-submit. What's another?
Committing to main.
Here, just talking to your mic.
Okay. What should this agent never do? I'll just point and then you give them the mic. That's very good.
Change input.
Great. Delete input, yes. What's another one?
Access the internet?
Okay.
Proud work.
So those are some things for the note-taking app. Allow, cancel, reset, allow preview, always show suggestions, never overwrite, and never auto-submit. If an agent can submit on your behalf, you've already lost user trust. Autonomy ends where user trust begins. Step 3, and this is the one people skip, map every state to a UI response. Parsing, show a subtle loading indicator. Suggesting, highlight the fields. Needed clarification, inline question. There's an error, you should have a clear recovery path. If the UI doesn't change, the user has no idea the agent is even doing anything, and they stop trusting it. And this is the final step. After defining states, transitions, and UI mapping, the abstraction choice becomes quite obvious. Given what we just designed, would you guys build it yourself or reach for a framework? Shout it out. Wow, I guess I didn't convince you guys enough. Frameworks are great when planning complexity demands them, but for UI-heavy applications with limited planning, such as the one we just did, front-end control decides, and a custom implementation would do just fine. So we just designed a safe, observable, agentic system, and we didn't even write a single line of code. Let that sink in. In summary, state machines make agent lifecycles explicit. Guardrails turn autonomy into something you can actually ship. UX-first design is what builds user trust. And to be honest, and be honest about when you actually need an agent. If you remember one thing from today, agentic AI doesn't break React. Unstructured autonomy does. Everything else is just applying these ideas consistently. Agentic AI isn't magic, it's responsibility. The more autonomy you give a system, the more design work you owe the user. Treat it like the software it is. As soon as we give systems autonomy, we take on responsibility for state, for UX, and for trust. Thank you everyone for your time and attention. Again, I'm Vinceline Bertrand, and if you're interested in connecting or have any questions, please scan the QR code. Also, we have 8 minutes left, so maybe a dance break, I don't know.
Give it up for guys. First ever college student, I guess.